Hey everybody, it's Mr. N, and this is another in the 2024 quick reviews. This is part 8, and this one is multiple choice with calculator required. And number 1 says, the graphs of the derivatives of the functions f, g, and h are shown. Which of the functions f, g, or h has a relative maximum on the open interval from x being between a and b? All right, so let's take a look at this. We're looking for a maximum, and these are derivative graphs. These three are derivative graphs, so that makes a difference here. So let's take a look at what we can do with this. Since this is a derivative graph, if I were to put a number line here and examine this, here is a 0, there is another 0 right here, and there is another 0 right there. The derivative is the slope of our original function because they want to know which of f, g, and h. So now we can notice that this is below the axes right here. These are all below the axes, and then you hit a 0, and then you continue on below the axes until you get to this point where now we are above the axes, and then here these are below the axes. So this is my f prime where it is. So I'm looking for a slope change because, again, the derivative is a slope. I'm looking for a slope change. Well, right here there is not a slope change, but right here we go from a negative to a positive slope, so that gives us a relative minimum, and over here we go from a positive to a negative, so that gives us a relative maximum. So we do have a relative maximum for the graph of f. Let's take a look at this one over here. If I were to make my number line, well, these are all slopes that are below. I hit a 0 right there, and then these are all slopes that are above. Well, below is a negative slope, above is a positive. That gives me a relative minimum here. Okay, and looking at this one, I don't have any zeros, so everything is above the axis, so all the slopes here are positive since the slopes are above the axes. So the only answer is the first one in this case, and it would be A, which is f only, that would have a relative maximum. All right, moving on, let's take a look at the next question. It says, let f be a function of, with derivative given by that, how many relative extrema does it have on this interval? Well, I'm going to tell you on this one, let's go ahead and plug this into our graphing calculators. So we are going to graph it with our calculators, and when you graph it, you should get a function when you zoom properly, where this is at 2 right here, this would be 3, and this would be 4, and it would go up, it would from here, because I only want it from 2 to 4, so it would go up and kind of cross right through here and then right through there, so it would go up and back down. I didn't draw it so great, but you get the idea, and then crosses again like that. Does that cross again? Okay, and then comes back down to 4 over here. All right, so now looking at this, I see an intersection there, 2, 3, and 4. Okay, so this is an f prime graph again. So it's changing slopes here. This is below the axes, negative to positive. This is positive to negative, and this again goes up above the axes and below the axes. So it is right here going negative to positive. There's one, positive to negative. So these are all the relative maximums and minimums, so they are all relative extrema. So there's 1, 2, 3, 4 of them. There's your answer for that one. All right, moving on to the next one. Let's slide this up, and it says the base of a solid is a region in the first quadrant bounded by the y-axis. The graph of y equals the inverse tangent of x, and the horizontal line y equals 3. The vertical line x equals 1 as well. For this solid, the cross sections, we're looking at cross sections here. So the cross sections are perpendicular to the x-axis, and they are a square. What is the volume of the solid? Okay, so let's graph this. Graph this on your calculator so you can get an idea. And when we do that, we have this particular situation where this is at 1. I'm kind of exaggerating this a little bit. This is 1, 2, and 3. So it says the horizontal line y equals 3. So let's just use another color here, and we've got that, and then we've got a vertical line at x equals 1, and I'm going to go like that. Okay, and then this tangent line comes through and goes something like, the inverse tangent line comes through and goes something like this. So we are looking at this region in here, and these are cross sections perpendicular to the x-axis, so they are in this manner, and these are all squares that are coming out of this. So these are squares that are coming out at you three-dimensionally. So if you want to imagine that, they're coming out of the screen right at you, and they are squares lined up. Okay, so we know when we do these problems that the volume is the integral of the area. And since they are perpendicular to the x-axis, I'm going to go from here all the way to 1. So this is the integral from 0 to 1 of the area. Well, what is the area? The area is a square. And in this case, that would be side squared. Well, the length of a side goes from this line 3 to the tangent line. So that would be 3 minus this inverse tangent of x squared. That's how we get that area. So that would mean the volume would be equal to the integral from 0 to 1 of 3 minus the inverse tangent of x dx. And go ahead and put this in your calculators. I'm sorry, squared right there too. I forgot to put the squared because it's the integral of the area. And put this in your calculators and you will get an answer of 6.6123, which is B. And there we go. There you have it. So thanks for watching. Hit that like and subscribe, and I'll see you guys in the next video.